Alright, we are going to be looking at trapezoids and kites today. So let's first look at theorem 6.15. That theorem states that the base angles of an isosceles trapezoid are congruent. So if we look at our isosceles trapezoid A, B, C, and D, our base angles are going to be congruent to each other. We know that those are congruent. So 6.16, the diagonals of an isosceles trapezoid are congruent as well. So that means our diagonal BD is congruent to the other diagonal AC. So let's look at some examples with the trapezoid. So if we have trapezoid ABDC, and we know it's an isosceles, so that means our legs are congruent, and we have base AB and CD. If we know the measure of angle C is 67 degrees, we also know that angle D is 67 degrees because our base angles have to be equal. So to find the angles A and B, these two have to add together to be 180. So if we do 180 minus 67, we're left with 113 degrees, and B has to be 113 degrees as well. Let's look at example 2. We have trapezoid TRAP. We know that diagonal TA is 5x plus 18, and the diagonal PR is 2x plus 3. So in order for us to find x, we know that both of these diagonals are congruent. So we know that 5x plus 18 equals 2x plus 30. So if we need to find x, we can solve. So we can subtract 2x to both sides. So 5x minus 2x is 3x plus 18 equals 30. And subtract 18 to both sides. So 3x equals 12. And our last step would be to divide both sides by 3. So x equals 4. So we found x, but now we need to find TA. So TA, we know equals 5x plus 18. But since we know that x is 4, we can plug that in. 5 times 4 is 20. And 20 plus 18 is 38. So TA equals 38. Let's look at the back side. So let's look at kites now. Theorem 6.17 states the diagonals of a kite are perpendicular. So if we create both of our angles, or diagonals, they intersect at a 90-degree angle. And the other properties of a kite be that the angles that are included by the congruent adjacent sides are bisected by the diagonal. So we know that these two sides in the kite are congruent as well as these two bottom ones. So what this is saying is that the diagonal, or the angles that are included by the congruent adjacent sides, those are bisected by the diagonal. Alright, so example 3. Example 3 says to find the measure of the numbered angles. So we know angle 2 is 90 degrees because it's perpendicular. Angle 1 is 39 degrees because since this is the included angle between our two adjacent sides, those two equal each other. And so now here to find angle 3, we know right here we have a triangle, so we have 39 and 90. So if we add 39 and 90, we end up with 129. If we subtract that from 180 because 3 angles in a triangle equal 180, we're left with that angle 3 equals 51 degrees. Last example. We know in this kite that angle IKS is 34 degrees. ETK is 24. And we want to find EIK, so we want to find this angle. We want to find ESK. And we want to find ETI, so we want to find this whole angle. So if we want to find angle ETI, we know that this is bisected, so 24 plus 24 is going to be 48 degrees, so this whole angle. We know angle ESK is at 90 degrees because it's going to be perpendicular. So then to find our last angle right here, we know that in a triangle that 90 plus 34 is 124. And in a triangle, they add up to be 180 degrees, so 180 minus 124 is going to equal 56 degrees. So our last angle, angle EIK, equals 56 degrees.